So next we have Nathan Rendy. Nate, since joining WJ in 2005, Nate has been a project associate for a broad range of assignments, including condition assessment of existing structures, structural testing and instrumentation, quality assurance inspections, and the development of repair plans and specifications. He specializes in applying non-destructive evaluation techniques, specifically impact echo, ground penetrating radar, impulse response, ultrasonic pulse velocity to evaluate concrete and masonry structures, and has developed and applied non-destructive testing to many unique situations. Nate has investigated concrete-related problems in numerous structures, including historic buildings, pre-stressed and post-tension structures, bridges, parking garages, slabs on grade and pavement, concrete liners and shafts and foundations. He is also involved in the measurement and analysis of vibration and has conducted several condition documentation surveys and construction vibration surveillance projects. So I'll hand it over to Nate.
Thank you, Charles. So this segment of this seminar is dedicated to pre-construction surveying. Bob and Arnie and I have obviously attacked a number of projects for the Iowa DOT and for other clients, and I'm frequently the one that's in the field during the pre-construction and post-construction surveying portions of these projects. So I think I have the experience to talk about this. First off, I'd like to discuss the Iowa DOT specifications, those special provisions. Jim and Brennan have already mentioned some of the clauses in the special provisions, but I didn't know where this fit into our seminar, and so I popped it in here. The specific Iowa DOT specifications that we've seen have included a couple of different types. The first being the special provision for pre-blast crack and damage surveying. This tends to specify that the consultant visually inspect and record existing defects in the identified structures, and the provision will identify those structures for us. That's part of the portion that the DOT develops. This particular special provision may apply to a pretty large radius for the project. For blasting in particular, that radius may be a few hundred feet, where you've identified the pertinent structures within that blast radius, and you want us to go through and at least visually inspect and document the condition, right? This doesn't always include then vibration monitoring portions of the work. The other special provision that we see often, more often, is the special provision for vibration monitoring. Sometimes that also says to protect historic structures. And in particular, this is basically a specification that requires us to develop a plan to minimize the potential for vibration damage due to construction and demolition activities, and then to monitor vibrations and crack behavior at the identified structures to protect them from vibration-induced damage. So again, the DOT typically does the homework ahead of time to identify those structures, and I know there's a number of divisions then that have a part in that, whether these structures be particularly historic or listed on the registry, be eligible for a registry, or just be sensitive structures that have been identified by the DOT. From our standpoint as a vibration consultant, when we receive the request for proposal from a contractor, that's the first time we see these special provisions, unless we're kind of combing the DOT bid site. And so we received that special provision, and therefore you've already done the legwork in identifying these structures and establishing what level of monitoring is required for each structure. Now, as the monitoring engineer, we may recommend modifying the subject properties based on our initial review of those properties, based on the work that we do on site during the pre-construction portion of the work. But note that this is typically done after the bidding process is already done, after we've been engaged by the contractor and we're on site, right? And so that's after a pre-construction meeting and these steps. And so that requires a change in budget and scope after the fact, right? What I'd like to encourage the DOT, and Brendan and I were talking about this during the break, is that there may be an opportunity for a little more communication between the monitoring engineer, whether that's us or another firm, the contractor, who a lot of times is not very familiar with with vibration consulting and these particular special provisions. You know, you're hiring a lot of different roadwork contractors. They've never seen this stuff before, and then have the DOT involved in that. That there be some meeting and some communication well before the project starts, so that we can discuss the requirements, so that we can adequately plan and schedule these pre-construction surveys, and make sure that we get in there ahead of time, that we notify the building owners as well. So what is involved in the pre-construction surveys? Specifically, the special provisions require that a professional engineer registered in Iowa and experienced in evaluating structural vulnerabilities and vibration monitoring be performing these inspections. There is a list of pre-qualified firms, Exponent, Kleinfelder out of Omaha, WJE, we're out of Northbrook, Illinois, and then Terracon Consultants has just been added, and they're more local in Des Moines, Iowa. The contractor is responsible for arranging with the property owner the rights of entry to their property in order to engage in the condition surveys, the vibration monitoring, and the crack monitoring. And this is another kind of contentious issue as to when in the process does this occur, right? And on a number of occasions recently during projects, we have had very little communication with the building owners prior to popping into town to do the condition surveys, right? And if the DOT is not reaching out to those property owners and the contractor is not, it's very hard to explain what we're doing when we just show up on site, right? So there needs to be that pre-work, basically. To go beyond just documenting conditions, specifications require that the pre-construction survey provide basically documentation of all aspects of the structural condition through observations, actual measurements, plan sketches, photographs, or any other data that the monitoring engineer may deem appropriate. We typically evaluate the risk from construction vibrations, right? Evaluate what construction activities are going to occur and what the risk from vibrations is. We will typically collect photos and develop plan view sketches or other sketches that indicates the existing vulnerabilities for those structures. The special provisions also ask that we prepare a monitoring plan. That monitoring plan basically includes a number of different clauses. The first being a description of the monitoring and communication equipment and alarm notification system. Bob will talk about this, I guess, this afternoon now, the different systems that we typically use for measuring and monitoring and then alerting both us and the contractor when exceedance occurs. The monitoring plan will describe the post-alarm survey in the event of a threshold exceedance. It typically requires a daily activity log of the vibration activity and the crack monitors. We typically provide ours on a weekly basis, and then the contractor or the DOT is involved in reading manually read crack gauges. Daily testing and logging of the entire network. Our seismographs are continuously monitoring and communicating with our servers back in Northbrook. We get notifications if an exceedance occurs, and then we get notifications on a daily basis every morning that particular monitor has uploaded its data during the night, right? And so that's our way to confirm that the monitor is continually running, it's running that morning, and the contractor can continue with his work. Typically, the monitoring plan also describes the construction methods and equipment chosen to achieve low project vibration levels. We generally kind of dump this on the contractor to describe their processes, to include that in the monitoring plan appended to kind of our monitoring plan and provided to the DOT. Special provisions ask for equipment installation and monitoring program. Typically that includes both crack monitoring and vibration monitoring in each of these projects. Vibration monitoring being the installation of seismographs that can continually collect data and communicate in real time with us and with you. Crack monitoring tends to be these manually read gauges. These are examples of avant-garde gauges that that basically get glued to either side of a joint or a crack. They can basically that both sides can move relative to each other, and you can just read the crosshairs as to what movement has occurred, right? But these obviously have to be manually read on a periodic basis throughout the construction, whether that be daily or at a periodic interval that should be determined by the monitoring engineer or the DOT. There are continuously read type gauges. You can instrument cracks to continuously read, to communicate with a network, to provide data in real time, but that's another level of monitoring. We'll also, in some cases, do some elevation and positional surveying, whether that be periodic or continuous. You can do building tilt monitoring, again, periodically or continuously. And then in some cases, there's some subsurface inclinometer that can be installed. Inclinometers are basically tilt monitors that are subsurface that get drilled down. You slide an inclinometer reader through the borehole, and you can plot then any changes in the movement of that subsurface material. Special provisions ask for vibration limits. Typically, this PPV level should be determined by the monitoring engineer. In no case, and again, this is an Iowa DOT specification, so in no case shall the PPV level exceed 0.2 inches per second as measured at or in close proximity to the structure. We typically adhere to this, although we'll recommend that a higher vibration level be acceptable at higher frequencies, and that's because higher frequencies tend not to be as damaging to your buildings, right, as Arnie described. The provisions provide that an alarm monitoring system shall signal when the vibration event equals or exceeds a threshold of 80% of the limit, and the limit is typically the lowest bound limit at the low frequency level, and that the contractor then immediately cease work if an alarm indicates that the threshold itself is exceeded, right? And so we're kind of counting on the contractor to adhere to this when they receive an alarm. The contractor then should propose alternate construction methods be used if the PPV limit is exceeded on a periodic basis. Special provisions also require post-construction surveying and reporting. So again, this is determining if any structural changes are the result of the construction activity. We've got all this vibration data we can look at. We know what the subject property has been subjected to, and then we go through and we performed a post-construction survey, and I'll talk about that a bit more later. And then the basis for payment is typically a lump sum cost. I know that's easiest for you during the bidding process. It's not easiest for us in some cases because we're getting limited information about these properties and what it's going to take to perform these surveys prior to the construction. We haven't even been on site typically when we're bidding on these projects, but if we recommend changes to that, then I understand that changes can occur. So what about the condition surveying process? General procedures for conducting pre-construction surveys. The first step is to notify the building owners and the occupants, right? So typically this is done by either the contractor or Iowa DOT representative from that division, from that district. In some cases, and we encourage this, the Iowa DOT will provide a letter of explanation to the building owner. That letter typically describes the construction project and the schedule. It will explain the condition surveying and monitoring program that we intend to do. It'll request permission to access the property, and it may offer to provide then a copy of the report and may also include the special provision that was included in the bid documents. There's a quote here from a recent letter of explanation in which it asks for participation by allowing a specialized firm, that's us, to access your building to complete the necessary condition surveys and vibration monitoring. Here it says, as an owner, you do have the right to deny access to the contractor, but we do feel denial would benefit, it should say would not benefit any party. So I think we believe this too, that this is meant to protect both the DOT, the contractor, and also the building owner, right? Document the condition and find out if anything changed. We schedule the inspection then. The time required varies widely depending on the particular building, right? So the time required may depend on the size and the type of the building, may depend on the building systems and finishes, right? Some finishes need more attention than others. The condition of the building. You can imagine that if a building is in particularly bad condition, it will take much longer for us to document that condition. Access is an issue. Usually single-family homes are pretty quick. You can imagine, though, if there's multi-tenant housing, then we need to coordinate that with each tenant. We need to get into each space and document the condition individually for each. Obviously, larger buildings, multiple floors, take more time. And then the scope of surveying. Sometimes the special provisions indicate that we will survey the entire property, right? And that's fine. Interior and exterior, we'll get into those locations. Sometimes it's more prudent just to survey a portion of the building, right? Particularly large buildings that are adjacent to roadwork, for instance. We may, and the provision may specify this specifically, or we may choose to propose just to survey one elevation and maybe the interior of the structure 50 feet from the north elevation. You know, something to limit the extent of that survey because you don't need to do the entire structure. Then we'll perform the pre-construction survey. During that survey, we will assess vulnerabilities of the subject property. We'll look at the building system and the materials that it's constructed of. We'll also assess the distance to the construction work. We'll assess and document the condition. Okay, so we'll perform a visual inspection and we'll document the observed distress. And I'll emphasize here that we typically focus on vibration-sensitive distress, right? Where we may note that there's water damage from leakage or deterioration from some sort of water infiltration. That's not particularly vibration sensitive, right? So you don't need to labor at it. But cracking, spalling, particularly sensitive situations to vibrations then need to be documented more thoroughly. Typically document using high-resolution photographs and video. We like to measure select conditions like crack widths, offsets, any existing settlement that may be observable, and we'll write that all into our pre-construction survey reports. There's also some secondary purposes to doing these pre-construction surveys. One is to answer homeowner questions, right? And we get a lot of those, especially if the homeowner himself hasn't had communication with the DOT or the contractor before we get in there. Another is to correct sensitive conditions prior to the start of construction. This may be sensitive conditions, structurally sensitive conditions, right? Situations where elements are unstable or in particularly bad condition and may cause, vibrations may cause more damage, maybe a life safety type issue, spalled concrete or loose window panes or something like that. It may be something as silly as, identifying that the particular owner has, a collection of sensitive plates or porcelain cats or something like that on their shelves, and maybe we recommend that those be removed or replaced. As Arnie mentioned, we do a lot of museum-type work, so in that case, then we're very sensitive to stored materials. So then we'll develop a survey report and monitoring plan. We'll submit that to the contractor, and an important step in this process is soliciting review by the contractor and the Iowa DOT. Sometimes I have to kind of harp the contractor to make sure that he's forwarding our reports to you, that the right district officers are looking at those reports and making sure that they accept the extent of the surveying and the monitoring plan that we've developed for those properties, that's acceptable before the start of construction. So then how about data presentation methods? What do we do to provide this data to you? The first is this is an example of photograph or video logs that may be developed. This is mainly developed for that first type of special provision that I mentioned earlier, the pre-blast survey, where we're asked to basically go through and photograph particular conditions, particular properties. Maybe we don't need to do an in-depth monitoring program for these properties. So this is a little more economical way of doing it, where we've got information on each property on the top of the sheet there, including a general description of the property. And then we've got a log, a photo log on the bottom. I'll blow that up for you. Basically, it includes the photo number, kind of the general location of those photos, and then a description of the observed conditions. And of course, we provide those photos to you with photo numbers. So you'll see there, description of observed conditions may just be overall photographs, maybe something like separation of molding, previous drywall cracking. I see one note there for drywall, east wall at window corner, 0.015 inches wide, right? So we're trying to be pretty specific in some of the measurements that we're taking on crack widths and other offsets. And then we typically provide a nice kind of log of the photos here as thumbnails. This allows you to kind of flip through the photos pretty quickly if you're going back to review the pre-construction conditions. I've got some examples of what we might take photos of specifically, like cracking in the stucco exterior wall here. Again, cracking of a wall, and I've shown kind of that photo with the crack gauge there. So we may have taken a measurement of that crack, included it on our pre-construction survey report, and included the photo as well. Here's another situation where we're measuring an open joint in a CMU wall, specifically with a ruler. Now we may go one step further and document condition on drawings. Sometimes we have drawings of these particular buildings ahead of time that we can use to take notes and to provide kind of a photo log of these areas. So here's a kind of a unique structure. I believe this was actually out somewhere in Philadelphia of a unique church where we had some elevation views that were already drawn up. We can use those then to provide our photo log and to provide and to indicate any observed distress. Now in this case, I don't think we have notes on distress, but we do in another example here. A lot of times we don't have drawings for buildings, right? They're just hard to find. The DOT doesn't have them, the building owner doesn't have them. So we need to come out and typically what we'll do is we'll just sketch up the property. We'll sketch up both exterior elevations to write our exterior notes, or we'll sketch up plan views of the interior floors, and that way we can kind of annotate those with our condition notes. Here's an example. This was out in Cherokee. I think Brennan mentioned this already. Is it US 57 or 59? 59. So in this case, there were, I believe, 12 properties that were specified in the provisions to be inspected. We monitored at 6 or 7 of them, right, trying to cut down the number of monitorings we needed, but still had the coverage that we wanted to protect all the properties. This was one in particular, an old bank building that was now a realtor. It's a, what is it, 2-story building with a full basement, concrete foundation walls, masonry and terracotta exterior walls there, and interior plaster finishes. So we found it best here to sketch up the accessible exterior elevations and provide figures, and that allows us then to record our photo locations and also to take some condition notes. So you'll see an example of that here. And what we're looking for here during the exterior survey, there are a couple of items that we found, particularly on this building. We found spalling and cracking of the architectural terracotta elements. We found masonry cracking, mortar loss in the masonry, a portion of the exterior masonry wall near the roof line that was actually bulging outward, right? So these are particularly sensitive conditions that we want to document pretty thoroughly. Here's an example of just some mortar loss in the parapet wall there. There's some spalled terracotta on the left. There's actually, kind of hard to see on this overhead, but there's a cracked terracotta piece there. Looking on the underside of the water table there, cracked terracotta piece there. Right, so we want to make sure that we're photographing and documenting these conditions. On the interior of the property, we recorded our notes on plan views of each floor. Typically, we draw in the major partition walls. We collect overall photographs of all of the surfaces. We record condition notes, and then we take up close-up photographs of the distress that we note. So here's first floor plan on the left, basement plan on the right. You can see there's a key in the bottom corner. So we like to kind of make a key for our condition notes. CXP indicates cracking in plaster, CXC cracking in concrete, SPG spalling of granite, right? So then we can apply all those photo notes there. If we zoom in a little bit on part of the basement plan, you'll note on the left that I've indicated CXC marked middle 0.075 inches. So there's a crack, a vertical crack in the foundation wall. We marked it at a particular location and we measured it, right? So now we can go back to that location and remeasure it at any time during the construction. Upper right, 5 foot 6 inches from the south wall, there's a crack that was marked and measured at multiple locations, top and middle. We've even installed an avant-garde gauge. That's that manual crack gauge on that crack. The monitor 2 location, that crosshair, is actually the vibration monitor that was installed in the basement. So we like to include all of this on our notes. And here's just a picture of kind of a close-up of a crack that was marked and measured with a crack gauge. In fact, I think you all have one that we left on here, so those are nice to use to measure and monitor cracks. And again, we've installed the avant-garde gauge at a couple locations at this property, and we get baseline readings then for those. So I do have kind of a walkthrough on a condition survey that was done during the Iowa 3 resurfacing in Pocahontas County. Brennan mentioned this one as well, kind of a unique church structure. Charles came out during the pre-construction survey, and that's where we met the first time, and I kind of walked him through our process here. But this particularly impressive church is a basilica-style cathedral constructed in 1901. Stone masonry foundation walls, right, not in particularly good condition. Then multi-wythe exterior walls, masonry walls with plaster interior finishes. And it's located about 35 feet from the roadway that was being reconstructed, right? And so that's the roadway there on the right of the picture. Here's the back of that church, so pretty large structure, and you'll notice the large bell tower up there as well. And the interior, wood frame primary floor, right? Primary being the congregation level. It did have a full basement level as well, which was slab on grade, concrete slab on grade. Some areas of that basement, you saw the exposed stone foundation walls. The rest of it was finished. And in the interior of this congregation level, obviously everything's finished with stained glass and with plaster. A lot of existing plaster cracking and water damage above and around these windows. So we had to take that into account. And then there is that masonry bell tower, which we had some access to from the choir level. We could climb up and get to this level where you had access to the interior masonry walls, but we didn't go much higher than that. I didn't trust both this ladder and the next floor up, and so we didn't have access. So in this case, again, we drew up or sketched up the interior plan views. So here's an interior plan of the basement level. Again, I've got a nice key indicating the photo numbers, the vibration monitoring locations, cracking in plaster and concrete and stone, and then we go through and record our notes and our photos. On the upper level, again, plaster cracking was prevalent, particularly adjacent to the windows. There was some staining and plaster distress resulting from water leakage. So you'll see some of those notes in the plan view sketch here. On the exterior elevations, then we again sketched up each of the elevations for the exterior. We took photos of all surfaces and recorded those photo numbers here, and then recorded any exterior distress that was noted. I have a list here: cracking of masonry and masonry joints at several locations on the main building and the bell tower. Some of those were marked and measured where we had access to them. Cracking of individual stone units and mortar joints on the exposed exterior portions of the foundation walls. These areas here below the masonry, those were exposed stone foundations. Exposed stone foundations were observed to have pattern cracking and surface spalling, kind of typical of freeze-thaw deterioration, kind of lensing deterioration of that stone, right? Which may not be particularly vibration sensitive in terms of stability of the structure or whatnot, but you may cause more damage and spalling of that stone. And then cracking in the sidewalks. So a lot of times we'll go around and we'll at least take some overall photos of sidewalks and other signs, anything that the building owner may be concerned about after the fact. We again provided our survey photographs in kind of thumbnail sheets, and then we provide those obviously digital photographs to both the contractor and the DOT. And then in this case, we actually had the opportunity to use a drone and take drone video of the upper exterior portions of the bell tower. Essentially, we've got a GoPro mounted to a drone, and it does allow you to get pretty up close and personal with upper portions of buildings that you may not have access to. And in this case, we flew all the way up on each elevation of the bell tower, and actually did the entire roof line of the property as well, just to pick out any additional masonry cracking that was observed along the roof line. It's kind of a toy at this point to us, but to some extent, we've started to use them for real work, and there's some FAA issues that we have to deal with too for using these things for commercial applications. I think you need to be aware of that as well. But we're trying to incorporate it into our work. It's kind of neat. Questions? Yes, sir.
So do you provide a copy of the report to the owner?
Well, that's always, a lot of times that's requested, right? Some owners are not particularly happy that we're walking through their houses and whatnot, and so part of what we tell them is that we'd be happy to provide a copy of the report to them. Usually I check with the DOT and make sure that's all right. You guys generally don't have a problem with that. In my case, I'm working for the contractor, right? And so I need to get that report to the contractor and the monitoring plan to him, make sure that he's happy with it before it eventually gets forwarded to you and then forwarded to the homeowner. So generally that takes some time, but I don't see why we can't forward this information to them. What that requires, though, is that if you've got a multi-property condition assessment program, you probably want separate reports for each property so they're not getting photos of somebody else's home or property, and so we have to kind of take that into account as well.
I should make a point too. You had a question earlier about non-historic properties. Pocahontas Church was on our radar. One of the things we deal with quite frequently is the quality of data that is in the database. That church didn't even have the right name in the database, so that was one of the reasons I had gone out to take a look. But the district had been contacted early on by this particular parish that had concerns about the project. So in terms of increasing the communication we have from project concept through environmental review and cultural resource consideration all the way through construction, I think Nate would agree that Pocahontas project worked well because the church chose to be active with us in communicating their needs. It turned out it had a really unique background and an architect that we didn't know had worked this far west in Iowa before. But coming back to the main point, we really had good communication, and that started with the district letting us know and bringing us in early too, so for what that's worth.
Let me spend just a minute of your time since everyone wants to go eat. There was reference to the specifications, and I've written a lot of them over my years, and I have always felt that specification work is the south end of a northbound mule. We need to stay out of means and methods for a contractor, yet we need to provide enough information so that they've got some idea of what they're bidding on. That said, for you, those of you who are administering contracts, at least out in the field, I'm always receptive to a well-thought-out, well-engineered, well-documented request to change the threshold levels, or at least the levels that are in the specification. That's got to come with enough poop that we understand what's going on and someone has definitely thought about it. But when we're writing a specification, at least initially, we don't have a clue whether somebody's going to go out, for an example, and use sonic pavement braking, or they're going to come out with the largest guillotine that you could ever think of. So we got to cover ourselves for that whole range of pieces that could happen. Once the contract is let, the contractor gets out there, has identified what equipment he's actually going to use, then I think there's an opportunity to take a look at that. Now, I know all of you who administer contracts, because I used to do this once upon a time, are about ready to throw tomatoes, because all of a sudden, now you're looking at how in the world do you actually get that documented and into the contract as far as for your contract administration. it'll take a change order of some type or another that you're going to need to do. But I'm just telling you that the default is set in the specs. We set that with purpose. We set it at some limit that we felt was very comfortable. But at that particular point in time, it's always been our intent that if there's a well-thought-out, well-planned, well-engineered request to change those levels, we'd definitely take a look at it, and we would be very interested in working with the contractor to do that. Okay? Another thing is that Bob and I were talking, and evidently there was other conversation. I think, based upon the new information that is at least published now, I think there's a reason to go back and at least talk about what kinds of things we can do to modify and update our specification. I'm not a bleeding heart, and I don't carry water for the contractors. Please understand that. But if there's a better way to communicate what our intent is, I'm all ears for that, to see if we can't improve our specification for this particular application.
Are you going to show your?
We have a question, maybe for Jim or for
When you're doing those condition assessments, do you have the information on what soil types are already present there at the site? No.
We typically do not, no. I mean, that's, I did have a couple of additional slides in my presentation originally talking about detailed vibration analysis, so actually going into that type of assessment, right? But to get that, you either need, the pre-construction kind of for that property, engineering reports, or you need to do borings yourself to get soil information. Sometimes you can look historically at the area and what we would expect, how traditional buildings are founded in those areas, and take that into account. But typically, that's not at least part of this assessment. I guess what we're hoping is that, if we think that's particularly important, that it would be done prior to and part of the evaluation of what properties were selected for this monitoring program.
So that would be basically a call by call basis on what you're seeing as part of your visit.
Right. Yep.
Okay.
Yep. And I think what Bob and I would hope at some point, we've got a 3-year on-call relationship with the DOT, is that if you want that type of analysis in a particular application, right? And it doesn't have to, you don't have to do something like that for traditional road work or demolition activities, but if you're doing blasting in an area that is particularly sensitive, that maybe we're involved prior to the bidding process and this type of spec writing, right, to identify the right properties and to make sure we understand how these blast vibrations will attenuate through.
Let's give Nate a round of applause for that.